Namaste everyone. Welcome to second PU's physics class. We were in moving charges and magnetism, correct? And we have finished that chapter, conversion of conversion of galvanometer into voltmeter, ammeter, and force on a charge moving in a magnetic field, things like that Ampere circular law, torque on a coil, everything. So we will move on to the problems. This is the first problem that we are going to discuss now. A uniform magnetic field acts horizontally and has a flux density of 2 Tesla. Flux density means the magnetic lines of force per unit area. That is called magnetic induction, B. That is Tesla. So a proton moves vertically downwards through the field with a velocity of so much. Find the magnitude of the force on the proton. So force Q into V cross B, QVB sin theta. That is what we are going to find out now. Find the magnitude of force on the proton. What is the radius of the path traced by it? You know that if a charged particle moves perpendicular to the magnetic field, then it experiences a force which acts like a centripetal force, and the particle starts moving in a circular path. So you can take the same force F equal to QVB sin 90 itself as the centripetal force m squared by r, and you can find out what is the radius. So that is the principle of cyclotron. Now, a uniform magnetic field acts horizontally and has a flux density of 2 Tesla. Okay, so this is 2 Tesla, acts horizontally, that is B. And a proton moves vertically downwards through the field with a velocity of 3 into 10 to the power 8, right? Proton moves vertically downwards with a velocity of 3 into 10 to the power 8. Very high speed it is. Problem is very ideal, right? So this is the speed of light. And find the magnitude of the force on the proton. Yeah, this is 90 degrees. So F is equal to QVB sin 90 sin theta. So Q is a proton, 1.6 into 10 to the power minus 19 coulombs, and velocity is 3 into 10 to the power 8 meters per second. Magnetic field strength is 2 Tesla, sin 90 is 1. So that itself gives you the force. 1.6 into 10 to the power minus 19, and that we will take later, into 3 into 2 is equal to 9.6. Yeah, 9.6. Oh, you could have done it directly. 6 into 1.6, 9.6 into 10 to the power, it is minus 19.8, minus 11 Newton. That is the force. That is the force acting on the charged particle. Now, what is the radius of the circular path? This itself should act like the centripetal force, m squared by r. So here only you will get the radius. Either you can equate this, or you can have the equation for radius itself. Or 9.6 into 10 to the power minus 11 Newton must be equal to mass of proton. It is 1.66 into 10 to the power minus 27 kg, which is to be known by the student. Mass of electron 9.1 into 10 to the power minus 31 kg. This is 1.66 into 10 to the power minus 27 kg. Mass of proton, square of the velocity 9 into 10 to the power 16, because it is 3 into 10 to the power 8 square, divided by radius. That is what you are going to find out. Yeah, I will rub this. So what is R? R is equal to 1.66 into 10 to the power minus 27 into 9 divided by 9.6 into 10 to the power minus 11. I think it doesn't get divided. Yeah, it's 6 times, but not exactly 6 times. We will do that since it is a theory problem. 1.66 divided by 9.6 is equal to into 9. Yes, the answer is 1.55. Yeah, 1.556. 1.556 into 10 to the power plus 11 minus 27 minus 16, correct? Oh, where did we go wrong? 9 into mv square, isn't it? So 9 into 10 to the power 16, I have forgotten. So it is only 1 point, this is minus, this comes to 27 and 27, so 10 to the power 0, only 1.556 meters, correct? Okay, we'll move on to the second problem. Right. A proton moves in the xy plane with a speed of 2 into 10 to the power 6 meters per second, making an angle of 30 degrees with the x-axis. Okay, shall we put it in the diagram form so that it becomes easier later? You need not peep into the problem again and again. Better we draw a diagram. A proton moves along the xy plane. Okay, this is xy plane, x and y. A proton moves along the xy plane with making an angle of with a velocity of 2 × 10⁶ meters per second, making an angle of 30 degree with the x-axis. 30 degree with the x-axis. This is the direction of proton, and 30 degree with the x-axis. But where is the magnetic field? A magnetic field of 1 Tesla is applied along y-axis. So here is B. B is equal to 1 Tesla in this direction. That means the angle that we need to consider, don't have color chalk, okay. The angle we need to consider is this one, that is 60 degree, not this one. That has to be very careful, because F is equal to, carefully, that has to be taken very carefully, F is equal to Q into V cross B. In all these chapters, starting from electric field, flux, and here the torque acting on a loop, everywhere, what is theta? It's not simple angle. Here you should be extremely careful. They will just hide you theta with some other values. It is an angle made by what and what. That is very important. Here it is F equal to Q into V cross B. It is VB sin theta. So velocity and B are having an angle of 60 degree. Calculate the force on the proton when the force of the proton will be 0. Of course, force on the proton will be 0 if it is moving parallel to the field, right? Sin 0. If proton moves along y-axis, force is 0. Okay, when it will experience maximum force? When it moves along x-axis. What is the force now? Force F is equal to Q into V cross B. F is equal to QVB sin theta. Q 1.6 into 10 to the power minus 19. Charge of electron and proton magnitude wise same. Speed is 2 into 10 to the power 8 something. 2 into 10 to the power 6. This is okay. A proton can achieve this, not like speed of light. QVB, B is 1 Tesla. Sin 60. F is equal to 1.6 to 10 to the power minus 13, right? Root 3 by 2. This answer is given wrongly in the textbook. I think I have given in the textbook by taking it as sin 30. It is not 30. It is sin 60. So you will get a different answer in the textbook. Whatever is mentioned, please correct it. Not textbook, that Fuse's book. Okay. So 1.6 into 2 into 1.732. You know what is root 3 divided by 2. Oh, you could have cancelled 2.77. Okay. Oh, you get this 2.77 1.6 into, so QVB, we didn't put B is 1 Tesla sin 60, we are getting the answer 1.6 into directly this 1.732, right, into 1.732. Yeah, you get the answer. This answer is wrong. 2.7 this is not 2.77 into 10 to the power minus 13 Newton. Yes. Sin 60 root 3 by 2, 1.6 into 1.7. This answer, this is 2.7 itself. It's correct. 2.77 into 10 to the power minus 13 Newton. Yeah, I don't know why did I get that. Into 2 will be 5.5. Yeah, right. That's correct answer. 2.77 into 10 to the power minus 13 Newton. We'll move on to the next one. Direct problem. Two parallel conductors carrying the same current are 25 centimeter apart. Okay, you know, two parallel currents, like currents attract, unlike currents repel in magnetic field. Two parallel conductors carrying the current, same current, so I will name them as I and I are 25 centimeter apart. It is in centimeter. And calculate the current in each wire if it experiences a force of so much per meter, right? You know, the force per unit length acting on acting between two straight parallel conductors carrying current in the same direction. Of course, opposite direction also. Only the force will be different in direction. µ0 by 4 pi 2 I1 I2 by D, right? IA IB by D. So I should remember here too, because finally you get, see, µ0 by 4 pi is 10 to the power minus 7. If you take all these 1, 1, 1, you will get 2 into 10 to the power minus 7 in the that definition of 1 ampere. 1 ampere is that steady current flowing through each of two infinitely long straight parallel conductors of negligible cross-sectional area kept in vacuum produce a force of 2 into 10 to the power minus 7. So 2, and this is standard for me. I will take always mu0 by 4 pi. For all the formulas, whether they get divided or not, I keep mu0 by 4 pi as if I keep 1 by 4 pi epsilon naught. So mu0 by 4 pi 2I1 I2 by d. That is the force, and this is Newton per meter because this is the force acting per unit length, not for the whole length of the conductor, only for 1 meter of the conductor. So they are asking you what is the, if the force is so much per meter, so you need not have L here. So I can directly substitute 1.5 into 10 to the power minus 3. If it is the force, what is the current? mu0 by 4 pi is 10 to the power minus 7 because mu0 is 4 pi into 10 to the power minus 7. What else? 2 I1 I2 I square, same current by distance 25 centimeters. Okay, I think okay, you have to use the calculator. That is equal, that implies so you will bring this here, 1.5 into 25 divided by 2. So we will write it once, 1.5 into 25 divided by 2, 1.5 into 25 divided by 2, 10 to the power minus 5, this is plus 7, 10 to the power 2 square root equal to I. Correct? 25, 1.5, 10 to the power minus 5, this plus 7 and 2. Yeah. So 1.5 into 25, 1.5 into 25 is equal to, divided by 2. It's a square root. Where is square root? Yes. 4.3, and this is 10 to the power 2 square. And its square root is 10, right? So into 10, 43.3. 43.3 ampere. Same answer. So direct one. But only the thing is you must know the theory behind all these things, that it is force per unit length and all. Okay, two long parallel wires carry currents 3 ampere and 4 ampere respectively in the same direction. Okay, rub this. Two long parallel wires carry currents 4 ampere and 3 ampere respectively in the same direction. Okay, 3 ampere and 4 ampere, same direction, 3 ampere and 4 ampere in the same direction respectively. The separation between them is 0.1 meter. Okay, then calculate the force exerted by one or the other per unit length. Yeah, F is equal to, so mu0 by 4 pi 2 IA IB by D. mu0 by 4 pi into 10 to the power minus 7 by 4 pi, 10 to the power minus 7, 2, 3, 4 by 0.1. Directly you can get the answer. I think this is a entrance exam question, direct one. 24, and this comes to 10 to the power minus 6. 24 into 10 to the power minus 6 Newton per meter. Newton per meter per unit length. That's the wrong answer. 10 to the power minus 6, okay, that is correct. 2.4 into 10 to the power minus 5, unit is wrong. Yeah, Newton per meter, direct one. Yes. The length and breadth of a rectangular coil having 25 turns are 0.55 meters and 0.12 meters respectively. It is kept with a plane parallel to a uniform magnetic field of induction 4 millitesla. Yes, we will bring it into the diagram form because we have got many data now. The length and breadth of a rectangular coil are 25 turns are 0.15 and 0.12. Okay, 0.15 and 0.12. Say this is 0.15 meters and this is 0.12 meters. Length and breadth of a rectangular coil of turns 25. So we have 25 turns. Number of turns, total number of turns are 0.15 meter and 0.12 meter respectively. It is kept with a plane, with its plane parallel to a uniform magnetic field. Plane is parallel to the uniform magnetic field like this, of value 4 millitesla. 4 millitesla is the strength of the magnetic field. For a current of 0.4 amperes, Yeah. In the coil, calculate the moment of the couple. Moment of couple means moment of force, right? Moment of the couple, that is torque. When 0.12 meter side is parallel to the field. Yeah, that is very important. This is parallel to the field. This is vertical to the field. We have already drawn it without reading. Actually, automatically, accidentally it was correct. So 0.12 meter of the coil is parallel to the magnetic field, and this is vertical. It is understood. So what is the torque acting? Torque is equal to, this electric field torque is equal to P sin theta. Here, Bm sin theta. Remember, this torque is only for one turn. If there are n turns, n. What is m? M is a current into area. It is the magnetic moment. Number of turns, B I into A sin theta. Remember, theta is the angle between normal to the coil and magnetic field, like this. If you take the coil like this, what is the normal to the coil? Normal to the coil and magnetic field, that angle. Here it is 90 now at this moment. So this is 90 now. Because coil is parallel to the magnetic field, but normal is perpendicular to the magnetic field. So that is theta, angle between normal and B. Okay, so that is here theta is 90. So what is the torque acting? Tau is equal to, number of turns in the coil is 25, and strength of magnetic field is 4 into 10 to the power minus 34 milli-Tesla, and current in the coil is 0.4 amperes, and area, length into breadth, 0.12 into 0.15 into, so N, B, I, A, 1, that is equal to direct multiplication. Of course, oh no, you can't. This can be taken as 100, let it be. 25 into 4 into 0.4 into 0.12 into 0.15. 0.72, 0.72 into 10 to the power minus 3, that's all. This much of Newton meter, torque, it is torque, Newton meter, or 7.2 into 10 to the power minus 4 Newton meter, that is also correct. So no problem. Yes, direct problems. A galvanometer of resistance 100 ohm gives full scale deflection when a potential difference of 0.05 volt is applied to it. Okay, a galvanometer gives full scale deflection when a potential difference of 0.05 volt is applied to it. Right. You take the galvanometer. A galvanometer of resistance 100 ohm gives full scale deflection when a potential difference of 0.05 is applied to it. It has not been converted at all. Directly apply some voltage. What is the maximum voltage needed for the galvanometer to show full scale deflection? That is 0.05 volt. Now we are interested in what is the current which will produce full scale deflection in the galvanometer, because every time we write Ig. So what is Ig? We know the Ohm's law. V is, I will call this as Vg. Vg is the voltage which will produce full scale deflection in the galvanometer. Then Vg is equal to Ig into R, correct? What is Ig? Ig is equal to Vg by R. Ig is equal to galvanometer current which produces full scale deflection, 0.05 divided by 100. Let it be like this. Now, what is the next part? This is to be converted into an ammeter to measure a maximum current of 5 ampere. So you have to convert it into an ammeter which will measure a maximum current of 5 amperes. What is the resistance of the ammeter? Okay. This has to be converted into an ammeter to measure a maximum current of, so range of the ammeter is 5 amperes. What is the resistance of the ammeter that has to be connected? You know that this is the galvanometer of resistance Rg, and the full current Ig process here, of course, not here, okay, like this, because the shunt resistance Rs keeps rest of the current that you are going to measure, right? That is I minus Ig. So out of the main current Ig flows through the galvanometer, which produces full scale deflection. The rest of the current is managed by shunt. And you know, Ig into Rg is equal to I minus Ig, I minus Ig, I will put it like this, I minus Ig into Rs. Okay, Ig into Rg, what is Ig? Ig is 0.05 divided by 100. 100 into Ig into Rg. 0.05 divided by 100. Hope you can see this, yes. Into Rg, resistance of the galvanometer, 100. That means this is Vg itself, correct? Because we will get it as it is. 100 is equal to I minus Ig. Okay, better we write this, right? 0.0005, correct? 3 zeros. Here already 1 zero by 100. I minus Ig. I is the main current that you are going to measure is 5. 5 minus 0.0005, correct? Into Rs, shunt resistance, Rs. What is the shunt resistance required? So this gets cancelled, correct? Now this can be taken as almost 5, right? Otherwise it will be 4.99995. Why need to write it? It is almost 5. So what is Rs? Rs is equal to 0.05 divided by this almost 5, right? This is almost 5, so 5. Rs is equal to 0.010. That's what you have. Even if you divide it by 4.9995, you will get almost 0.0099. So that is almost your same answer. So that is the shunt resistance required to convert it into an ammeter of range 5 amperes. So when see, that is what I was talking in theory. 5 ampere passes through this. Out of that 0.0005 ampere passes through this. 4.9999 ampere passes through this. Now the question is, when the needle shows full scale deflection like this, what you have to write here? Whether you have to write 0.0005 or 4.995 or 5, you have to write 5 because you are reading this one, right? You have to write 5 amperes here in the scale. Okay. When a certain current is passed through a galvanometer, the deflection produced is 40 divisions. Okay. When a certain current, you have to assume symbol, some I, right? When a certain current is passed through the galvanometer directly, no parallel shunt, no series resistance, nothing. When a certain current is passed through a galvanometer, the deflection produced is 40 divisions. So directly you pass that current. Rg, G, galvanometer. When certain current is passed through the galvanometer, the deflection was found to be 40 divisions. Right. When a shunt of resistance 3 ohm is connected across the galvanometer, so in the same situation, same Rg, same current, but we will have a bypass now. When a shunt of resistance 3 ohm is connected across the galvanometer, the deflection falls to 2 divisions. Now it is only 2 divisions deflection. That means current through this, because the deflection, if at all there is deflection, that is shown by the current through the galvanometer. Because current through the galvanometer deflects the coil. Here that full current is passing through the galvanometer, so it was able to produce 40 divisions. Now full current I cannot pass through the galvanometer because there is a bypass. So that is the shunt resistance. That shunt resistance receives some current I minus Ig, and only Ig passes through the galvanometer now. That Ig produces 2 divisions. So compared to this I, what should be this Ig? Since divisions drop from 40 to 2, current should have dropped by the same amount, because more the current through the galvanometer coil, so coil will be like this, more will be the torque, more will be the deflection, because we have seen the torque formula, Bm sin theta, that is Ia sin theta. I controls the deflection in the coil. So since current controls the deflection, more the current, more deflection. So when I have I, deflection is 40. When I have Ig, deflection is 2 divisions. What is this drop? 20 times it has dropped, right? So I produces, okay, 40 divisions were produced by I. 40 divisions were produced by I. 2 divisions were produced by what? That is Ig, right? Cross multiplication. 40 divisions deflection was produced by I. 2 divisions by what? That should be Ig. So this Ig is 1/20th of I. I by 20th is Ig. It is 1 by 20th of I. So Ig is 1 by 20th of total current, because the number of divisions the deflection has been dropped by 1 by 20. Now rest of the things you can do, write the formula. Now their question is find the resistance of the galvanometer. This 3 ohm is given. Ig into Rg, again, I don't remember the final formula of the derivation. I again go for the theory only. The problem solution becomes easier. Otherwise, if you are just sticking on to the formula, it doesn't give you any meaning. IGRG is equal to 3 ohm into I minus Ig, correct? 3 into I minus Ig, Ohm's law. Voltage across this and this are same, Ig into Rg, I minus Ig into 3 ohm. Ig can be expressed as I by 20, Rg must be, Rg is given, right? No, Rg is not given, Rg is the question. 3 into, again this I is I minus Ig, I by 20, correct? Ig is I by 20. Here Ig is I by 20, here Ig is I by 20. So solve this now. Here I can be taken outside. Where should I write it now? Okay, I will write it here only. I will write it here. I by 20 into Rg, I by 20 into Rg must be equal to I into 3 into, hope you can see that, right? Okay, I doubt whether you can see it or not. I'll write it here. Here you can see it clearly. So the next step goes like this. I by 20 into Rg is equal to 3I, I will take 3I common. 1 minus 1 by 20, 19 by 20. I gets cancelled, even 20 gets cancelled, finish. Rg is equal to 19 ohm. Oh, we don't get 19 ohm, correct? Sorry. 3 into 19, right? 3 into 19, 20, 57 ohm. It is right. Correct answer. So you must know how to convert Ig in terms of I. That 40 divisions drops to 2 divisions means Ig should be 1 by 20th of the full current I. That's all you have to do. The resistance of a pointer galvanometer is 50 ohm and it has a scale in which there are 30 divisions. Okay. We will move on to that. We will rub this. Resistance of a galvanometer, pointer galvanometer is 50 ohm. Rg is 50 ohm. Okay. And it has a scale in which there are 30 divisions. Okay. 30 division scale. Okay. It produces a deflection of 1 division for 0.1 milliampere. Okay. How do you convert it into an ammeter which can measure a maximum current of 3 amperes? Yes. This is the reverse of the previous problem. You see, for producing 1 division, you need a current of 0.1 ampere. What do you mean by 0.1 milliampere? For producing a 1 division deflection, you need a current of 0.1 milliampere. What do you mean by Ig? Ig is the current required to produce full scale deflection, that you know, right? If it is so, then, so Ig is the current required to produce full scale deflection, then what is Ig? Ig is nothing but, for how many divisions? 30. For 30 divisions, how much? That is Ig. 1 division 0.1 milliampere. 30 divisions how much? So what is Ig? Ig is equal to 30 divisions into 0.1 milliampere. That is equal to 3 milliampere is Ig. That's all. Then our usual diagram. This is Rg, 50 ohm. That is Rg, and this is the current to be measured. It should convert it into an ammeter which can measure a maximum current of 3 amperes. And this is the shunt required. Don't know. And here should be that 3 milliamperes, that is 0.003 amperes, right? 0.003 amperes. Subtract this from this, that is 2.997 amperes, correct? 3 minus 0.003, 2.997. Okay, what is the shunt? So directly formula from the diagram itself. Ig into Rg is equal to I minus Ig into shunt resistance. Ig into Rg, Ig is 3 milliampere into Rg 50 ohm, 3 milliampere into 50 ohm is equal to 2.997 into RS. Or you can take it as almost 3, then it becomes 50 ohm, right? Not 50 into 10 to the power minus 3. So you can, if you can take this as almost 3, 50 into 10 to the power minus 3. So that implies RS equal to 50 into 10 to the power minus 3 means 50 by 100. 1 0 cancels, 0.05 ohm. 0.05 ohm. 50 into 10 to the power minus 3. So 1 0 here, 2 zeros here, another 0. 0.05 ohm. Yes. Next one. Two long parallel wires carry current 6 ampere and 4 ampere respectively in the same direction. The separation between them is 0.1 meter. Calculate the point between them where the net magnetic field is 0. Okay, we'll do that. Right. Two long parallel wires carry current in the same direction, 6 ampere and 4 ampere. Okay. Okay. They are separated by 0.1 meter. Calculate the point between them where the net magnetic field is 0. You see, what is the direction of magnetic field produced by this 6 ampere? In between them, point between them, it is like this, into. So somewhere it is into. So I will call this as conductor A and conductor B. So this is the magnetic field due to A. What about this one? Like this, right? It is coming out here. Of course, it will be going in here, but it is coming out here. So here, if it is coming out, then what I have to write? Yeah, it is coming out means dot. So they will cancel, provided the value is same. If the values are also same, they will cancel. So how do you select it? Let it be X, then this is 0.1 minus X. Total is 0.1. Now, you know, magnetic field produced by a straight conductor, it is infinitely long, right? Two long parallel conductors, like this. Magnetic field produced by a very long straight parallel conductor at a point here is B is equal to mu0 by 4 pi 2I by D at a distance D, current carrying conductor. mu0 by 4 pi 2I by D. Whereas at the edges, if you go to the extreme end and find out the magnetic field here, B is equal to mu0 by 4 pi I by D. Half of that we have at the center. If it is infinitely long and if you are at the edge, from the edge it is infinitely long to the other side. mu0 by 4 pi I by D. So now you have to find out at the somewhere at the center because it is infinitely long on either sides. Yes, here. Now magnetic field produced by A must be equal to magnetic field produced by B. That is the only criteria required here. Everything else is satisfied. Direction ulta, right? This one coming out, this one going in. We have got the direction opposite. So just equating the two equations, enough. What is the magnetic field produced by first one? mu0 by 4 pi IA by what is that, X. Magnetic field produced by second one, 2 IB by 0.1 minus X, because for this one distance is 0.1 minus X. That implies, so you can cut off this 2, you can cut off. IA is 6 by X is equal to 4 by 0.1 minus X. So cross multiply, 0.6 minus 6X. 0.6 minus 6X is equal to 4X. Okay, then what I can do, this is 10X. 0.6 is equal to 10X. So what is that implies X equal to 0.06. So from here 0.06 and here 0.04. Totally it is 0.1. Now can't you do this by shortcut method? Yes. What you can do? You see, in this formula, if the magnetic field has to be same, for the conductor for which current is more, the distance should be less, isn't it? Sorry, distance should also be more, so that magnetic field produced by both the conductors are same. Magnetic field produced by 6 ampere source and 4 ampere conductor, if they have to be same, if numerator is more, denominator should also more, so that B is same for both. And if it has to be so, okay, for 6, you divide the distance. You see, current and distances are here. If you bring this here, B is a constant, so I is directly proportional to D. That means if I is more, D is more, because everything is constant. You have come to know that everything is cancelled here. So I is directly proportional to distance if you bring it here. B is also constant for both of them except their directions. So I is proportional to D means divide this D in the ratio of I. What is the ratio of I? Shall I rub this? Ratio of I is 6:4. That is I ratio. Divide D also in the same ratio. That means total is 10, right? Out of 10, first one should be 6. What is out of 0.1? You will get it directly, right? Distance has to be divided. Out of 10, this current is 4. 6 plus 4 I did. And what is the distance of part? 0.1. You will get the same answers, 0.04 and 0.06. So that's all this here, I think. Yeah. And we will meet with a few more problems, right, later. So thanks for watching this class. Hope my video hasn't gone to the second one. So take care of yourself. Work out more problems in this chapter. Very important chapter. You should work out. You should have a list of all the formulas first of all. Then work out the problems. Thank you.